Hi class, we are now on chapter 7.7. We are going to break apart chemical equations into molecular, complete, and net ionic. Okay, so let's go over definitions so you understand. A molecular equation is an equation showing the complete, total, neutral formulas. That's what we've been looking at. So the normal, up to this point, normal balanced equations, that's considered a molecular equation. Complete ionic equation is the same equation, however, it's broken up completely into ions, except for anything that is a solid. That stays in the solid form. And if there's coefficients, this one doesn't show, these are all ones, but if there was coefficients, you would also use the coefficients. You keep it balanced even if it is an ionic form. Writing a complete ionic equation, separate only aqueous ionic compounds into their constituent ions. Basically, that's fancy for saying we only separate aqueous ionic compounds, but we do not separate the solid. Do not separate solid, liquid, or gaseous compounds. They stay intact. So water would stay intact, O2 gas would stay intact. Okay, so this is what we're going to do is cover this ionic form. So in the complete ionic equation, some of the ions in solution appear unchanged. So when we break this into the full form, which is also here, you see it here, but it's broken apart except for the solid. What you notice is that nitrate and sodium look exactly the same on this side. They're called spectator ions. They do not participate in the main reaction of the solid. Only the silver and the chloride do. So these are spectator ions. If they look exactly alike on opposite sides, they are spectator ions. So the difference now, okay, so we have now looked at, this is a complete ionic equation, meaning everything's in ions except for precipitation. And now we're going to look at net ionic, which means strictly the ions that create the solid. We remove the spectator ions out of it. That is a net ionic equation. So we start with a molecular. We go to the ionic, complete ionic, which everything except for the solid or liquid or gas. And then we remove the ions, the spectator ions, and we end up with the net ionic. So just what creates that solid, those ions that formulate the solid. That is a net ionic equation. So here is a summary. A molecular, I found this online. I was trying to find something that had it intact. Now the only thing is this doesn't have the physical states, except not in all of them. It shows you which one that is the solid and everything else is defaulted to aqueous. I don't like this, but this is what I found. A molecular equation is a chemical equation showing the complete neutral. So here's a word equation. If you were given this, you would have to complete it into this with the physical states. So complete, they call this a complete chemical equation. It's also a molecular equation. Then you are asked to put it into a complete ionic equation, and that is breaking everything apart. Yes, it also has ones. Just ignore that. But if that helps you to learn how to break these up, by all means do it. And then as you start doing them, you won't even have to do that anymore. So then you break everything up except for the product that is a solid. Then you look to see which ones which ones do not participate in the solid. You should expect to see the spectator ions on both sides, and you do. You cross them out, and that gives you the net ionic equation that produces the solid. Okay, so which chemical equation is a net ionic equation? That equation which only show the species that actually participate in the reaction. So if we look here, that's a molecular. This is a complete ionic. You see the coefficients in front. You have to have everything. And this is a net ionic. Only shows what participates in the solid. Consider this precipitation reaction occurring in aqueous solution. Write a complete ionic and net ionic. Why? Because this is already molecular. So we are going to break this apart. Okay, so I put up the definitions. We already have the molecular. We want a complete ionic. And then from the complete ionic, you can get the net ionic. So there's definitions here again. So an easy way to do this is put lines. Break them up into the lines. This will allow you to put these into ionic form. And this one has some coefficients to allow you to see how to do that. So remember, we uncrisscross these. So this 2 goes back to here. So there's the lead. Now nitrate has a -1 charge, so we don't have to worry about that. However, there's 2 of them, so we have to make sure that the 2 is there. We have 2 lithium, and we have 2 chlorides, so that makes it nice because these cancel out the 1 to 1. Here we have a solid, so that's easy. We don't have to worry about the solid. We have 2 lithium and 2 nitrates. So we now have the complete ionic equation. So if it makes it easy, draw lines, uncriss-cross things, and remember the charges. That also has to go with them. Okay, next one. Let's look at net ionic. So we cross out the spectator ions, and what you find left is just the ones that participate in the actual formation of a solid, and that is our net ionic equation.